because your calculators may have been used by grade 12 students. And if you look at the top of your home screen, it should say degree right there. If yours says radian, you're going to have a problem if it's set to radian. So we got to fix that real quick. So just press the mode button, which is right here. It's next to the second button. Just press mode, and then go down to where you have the option between radian and degree. You just want to make sure you select degree. So you're going to go over to degree and hit enter, and then your problem is solved. Okay, so it will stay in degree until next year when you're in grade 12, then we switch it to radian. Yeah.
I have a question. If it's black, then we use like.
Yeah, and in fact, yeah, if it's highlighted, it's good. If it says degree at the top, you're definitely good. Okay, that's the only thing I wanted to do before we get started. Okay, all right. So, what are we? March 2026. Okay. So let's get started. What is the difference between this trig and the trig you've kind of learned about in grade 10? Do you remember SOHCAHTOA in grade 10? Did your teachers use SOHCAHTOA? If they didn't use SOHCAHTOA, they may have used sine, cosine, tangent. You may have used that. What was the big condition for those to work? Like, what kind of a triangle did you have to have? Right triangle. Yeah, you had to have a right triangle, or else it didn't work. Okay. In grade 11, we introduced different trig that works for any type of triangle. Okay. It's called, the first law that I'm going to teach you about is called the sine law. Okay. Once we've introduced the sine law, we'll introduce cosine law. So this is the good part about this trig, is there's only the two laws that you're going to need to know. Sine law, cosine law, that's it. You can solve any triangle, whether it is right or if it is a non-right triangle, it doesn't matter, it will work every time. Okay, you just have to apply it properly. So in intro to applied and pre-cal, that was last year, you learned about primary trig ratios, sine, cosine, tangent. You also learned about sine inverse, cosine inverse, and tangent inverse, right? You may have, this is when you have the angle, this is to find the angle, okay? And if I would have been your grade 10 teacher, I would have taught you SOHCAHTOA, right? Sine is opposite of hypotenuse, cosine is adjacent hypotenuse, tangent involves opposite and adjacent, okay? But it only works with right triangles. So primary trig ratios only work with right triangles, okay? So primary trig ratios only work with right triangles. In grade 11 applied, that's the course code, we will learn to solve oblique triangles, okay? So we'll learn to solve for oblique triangle. What is an oblique triangle? A non-right triangle. I don't even know if that's an official term, but it's anything that isn't a right triangle. Okay, so if you have one of these, if you have a right triangle, or if you have one of these, okay, you would have been able to use SOHCAHTOA. But now, okay, you may have an acute triangle, or you could have an obtuse triangle. It doesn't matter. If you have a right triangle, all of these we can use sine law or cosine law. works with every scenario. Okay. And what does the sine law ultimately say? Just so you know, sine law is what mathematicians used to come up with SOHCAHTOA, right? So SOHCAHTOA is a derivative of sine law, cosine law. Okay, so just so you know. Sine law in a nutshell. So this is study sheet material right here. And I'll just give you a triangle that looks like this. We'll make it look like an oblique triangle. And I'm going to use letters A, B, C just because that's what we do in general. But remember, these letters could be anything, right? X, Y, Z, you name it. If you've got capitals for the corners, we use lowercase for the side lengths, guys. I don't know if you remember that. If this is capital A here, this angle, then across from it we've got lowercase a. If capital B is up here, then the side length across from it we refer to as lowercase b, and so the last side C will get a lowercase c. So if I don't give you letters for the angles, you come up with them, okay, because it could be a word problem, right? And you could call this like camp. This is camp. I leave camp, that's C. Then I go right to my first site, maybe a cliff.
Can we please get a custodian to open up the office in room 20, a custodian to open up the office?
So anyway, so this is what sine law says. If you were to take sine of angle A and divide it by side A, the side that's across from it, right? That's what we're saying here. That would be exactly the same as sine of angle B divided by side B, which in turn would also be the same as taking the sine of angle C divided by C. This is always going to be true, okay? This is the one I'm going to use every time. If I use sine law, I'm going to use this property. However, we're not going to have three proportions like that. I will never do that. I will only pick two proportions, and then it will turn out into a cross multiplication and division. Okay, we're going to be strategic about it. But I need to tell you the variation of it. The variation of the sine law is where you flip this original one, where all the side lengths are at the top and the angle, sine of the angles are at the bottom. So I'm just going to give you that version, even though I'm not going to use it. Okay? But I'm going to use the top one, okay? So that's sine law in a nutshell. So let's test it. See if this is actually true. Okay? You got this? You got the formulas? So here we go. This is drawn to scale, okay? Drawn to scale, meaning all these sides are actually, they measure, this is supposed to be 9.51 centimeters. This is actually 9.5 centimeters. This is 8.03 centimeters, and so forth. Everything is in centimeters if you want to write that down. And these angles are actually, if you were to measure this angle, you would actually measure 101.39 degrees, okay? So let's take sine of 22.7 degrees and divide it by the side length across from it, 3.74 centimeters. And then we'll take another pair. We'll take sine of B, which is 101.39, divided by 9.51 centimeters. And then last but not least, we'll take sine of 55.9 degrees divided by 8.03 centimeters. So let's divide this. So if you take your calculators, I would encourage you to do that. Okay, I'll just go sine, you press sine of 22.7 degrees, close the bracket just to make sure it doesn't mix it up. And let's write down at least the first couple of decimals. 1, 0, 3, 1, and that keeps going. And that's supposed to be exactly the same as sine of 101.39 divided by 9.51. 0.10308. And then we take sine of 55.9 divided by 8.03. 0.1031 and so forth. If you were to round them all to, let's say, 2 decimals, 0.10 is equal to 0.10, which is equal to 0.10, right? You'd notice a little bit of a variation, but that's just because we had to round. I had to round my angles to a certain degree. If I had given you all decimals everywhere, all of these values would have been exactly the same, okay? But when we round to 2 decimals, we definitely can see that sine law is accurate, okay? Also, if you were to add up the angles, they should add up to 180, okay? And I'll make a note right here. There's a relationship between the angle measure and the side length across from it, okay? Which one is your largest angle out of the 3? You can tell that it's B, right? Based on the number and also based on the opening. What do you notice about the side length across from it compared to the other side lengths? Right? It's the longest side, the largest angle across from it. You notice that? What about the smallest angle? This is the smallest angle, right? What do you notice about the side length across from it compared to the other side lengths? It's the shortest. That is always going to be true. What about this isn't a term, okay, don't quote me, the middleist. The middleist angle is across the middleist side. It's not a term, I'm just making that up, right? But if you just check largest angle, longest side, shortest, right? Shortest side is across the smallest angle, you know you're doing something right. I'm not guaranteeing you that your answer is correct, but you definitely know that things are the way they were supposed to be. Okay, so note, largest angle always across longest side. Smallest angle. Do you know this? This is basically saying copy paste, right? Smallest angle always across shortest side. Okay. This note is often overlooked, but I do ask you in some way, shape, or form. I'll check to see if you are aware of this. Okay, so I might ask you, you know, you need a certain angle to fit something in that corner. Can that be done? Instead of checking every single corner, every angle, just find the largest angle. If the largest angle can't accommodate that object, then it can't be done. You shouldn't have to check all 3, okay? And vice versa. Keep going. Here are your 3 scenarios. Here are your 3 scenarios where sine law works. Okay? But I want you to remember this. For sine law to work, you need at least one pair. That is imperative. Okay, pardon the pun. Actually, pun intended. Okay? Imperative. It is very important to have a pair. This means that you need a known side and the angle opposite to it. So use sine law in the following cases. This is also a big note. Note when you're given 2 angles, you can find the third angle before you continue. If I give you two angles, just go ahead and find the third. Just do it, okay? It's going to help you out. So here it is. The first scenario is we call it the AAS scenario. What is that all about? That's when you're given any two angles. Just pick any two angles, okay? For our intents and purposes, I'm going to say, how about they give you this angle and they give you that angle? And they give you one side across one of those angles. Okay, so check. You see your pair here? This would be your pair. And I will highlight that. You've got the side length and the angle that is your pair. So you know sine law would be applicable here. The next one is side-side angle. Okay. That is a scenario where when you start sketching your diagram, how many sides will be given? Two sides, side-side angle. Pick any two sides, and you'll have an angle across one of those sides. Boom, there's your pair. If you see a pair, it's not even a question. Sine law is going to be your go-to law. You're going to have to pick between sine law and cosine law. Right now, all we know is sine law, but you're going to have to pick. This last one is called angle, side angle. And I will call this the hidden pair. I don't really need you to memorize these necessarily. I don't. I just need you to recognize the pair when it's there. So what does this mean? Let's draw our triangle. So you've got two angles, correct? Notice angle, side angle means that the side is the one that connects those two angles. It's almost like the side in between. Okay? Do you have a pair? Is there a pair? No, but it's hidden. If you've got two angles, you can find the third angle, correct? Yes, okay. Find third angle. Okay. All right. Where's your pair? There it is. Okay. There's your pair. I'm going to add something. Find third angle. We're going to use sum of triangle. Mr. Erickson, shouldn't I have done the same thing here? Remember, Mr. Erickson, the first one had two angles. Find the third angle. I would say yes. Just find the third angle. However, as soon as I identify a pair, I'm good to go. Okay, I'm good to go. It's sine law. Okay? Okay. Here it is one more time. Largest angle across longest side. Smallest angle across the shortest side. You can't emphasize things too often, okay? So here we go. Draw and label, so no diagram provided. You're gonna have to be comfortable with sketching your own diagrams, okay? Sometimes I provide them, but with word problems, you're gonna have to depict your own. So if you've got triangle DEF, it tells you that these are the angles, right? D is 60, side D is 5.2. We know these are across from each other. Angle F is 80, side F is 8.3. So when you sketch this, I don't need you to draw this to scale. But I would say it's a pretty good bet not to make it a 90. Okay, don't make it a right triangle. And then start anywhere you want and go clockwise. Start anywhere you want. So I'm going to start with angle D. I'm going to go D, E, F. Mr. Dixon, what if I forget what clockwise is? What if I go counterclockwise? The good news is you'll still be okay. It won't affect the way you do things as long as you label everything consistently after that. So angle D is 60 degrees, so you put the 60 in here. Side D is 5.2 centimeters. So make sure these are across from each other. Angle F is 80 degrees. Side F is 8.3 centimeters. You actually have two pairs there. I just wanted you to check just by looking at it. And just so you know, I would expect you to realize, oh, angle D, side D, that is a pair. Angle F, side F, that's also a pair. Okay. I would like you to recognize that because you could have told me right away, Mr. Dirksen, there's going to be sine law. I know it. How do you know it? Because there's a pair. I can see it already. Okay. Let's keep going. Let's actually calculate. Let's use sine law. We're going to first calculate sides. Pay attention because right after this, I'm going to ask you to try it already. That's how smart you guys are. I only need to give you one example. So let's look at this. Let's imagine for a second we don't know that this is sine law. Let's imagine we have to pick. You see your triangle. You have this angle, and this is side C, right? Across from it. This is your pair. Okay? So pair means there's a sine law situation. There's no question about it. And I start with the pair. That's usually what I start with. So let's go for it. Sine of 62 degrees over 4.5 meters is equal to, which side am I asked to solve? Side B. Where is side B? If angle B is here, side B is there, correct? So this is my unknown. That's the question mark. I don't know what it is. Which means that I would have to go sine of B over side B, correct? That's the only way that would work. If I want to find that, I need to set it up like this. I don't know angle B at the moment, but I've got two angles, correct? So let's find angle B. Angle B is 180 minus 38 minus 62. And that angle B is equal to 80 degrees. Important, not the answer, but it is important. And now, if you for your notes, right, we're going to say, we didn't know that, but we could easily find it. Okay, we didn't know, but now we know what it is. So I had to do this side step here. And now I can complete this, okay? Sine of 62 degrees over 4.5 meters is equal to sine of 80 over side B. I know this looks kind of busy right now, but this is cross multiplying and dividing, right? You've got two fractions. All of these are numbers, right? You can turn all of these into numbers. So to solve for side B, we just cross multiply and then we divide by what is left. So this times this divided by that. I want you to show me the work. And you might say, Mr. Hicks, isn't it sine of 80 times 4.5? Yes, but it doesn't matter which one you write first. I tend to write my side length first so that sine doesn't mix up the 80 and the 4.5, like when they're right next to each other. I tend to do this first. So let's calculate that. Once you've copied it, just grab your calculator. Maybe clear your screen for now. So you go 4.5 times sine of 80. I would figure out what that is first. Then I go divided by sine of 62. So that's your final answer, 5.02. And I'm looking for the side length, right? My side lengths are all in meters. So that's it. Yep. Okay. Okay, let's do, I know they didn't ask for it, but we're going to do this anyways. I'm going to ask you to break this up. If you don't have enough room on the side, do it underneath what I just did. Try to find a little bit of space. We're going to solve for side A. Side A, right? What is side A? I'm going to do that on the side. Watch what I do. I start with the same pair. I start with the pair sine of 62 over 4.5 is equal to sine of angle A over A. You can skip this step that I'm giving you right now in the future. You can go ahead and put numbers in right away. Okay, yeah.
You can use starting B now, right?
You could if you wanted to, because you've got a point, Ranveer. You've got a pair here now, right? Because you know what B is.
Yeah.
Could you use it? Yes. But what if you made a mistake here? If you made a mistake, it's going to come with you to finding A, right? So my preference is stick with the pair that you're given. But you've got a point. Yeah. So we're going to go sine of 62 over 4.5. That's sine of 38. I now have to use 38, okay? Over A. And then we're going to find out what A is. We're going to go 4.5 times sine of 38 divided by sine of 62. That's 3.14. You round to 2 decimals. Everything gets rounded at the end to 2 decimals. Whether it is an angle measure, or a side length. I'm getting you ready for grade 12, applied, right? The province always wants a final answer to be at least to 2 decimals, rounded to 2 decimals, final. Only if it's money, you have to have 2 for sure, no more than 2, okay? I'm gonna highlight the angles, different colors. Maybe the 80, is this gonna work? The 80 is already highlighted, so technically if you want to skip that one, that's fine. Then I'm going to highlight the 38 and just make the 38 appear right there so you know what happens, right? And I will give you a note here. Note you need at least 3 values to solve, okay? It's to solve triangle. Like if the question doesn't give you at least 3 values, you can't solve it. So there's any combination. But another note, angle, angle, angle is unsolvable. Okay, you can't solve a triangle that only has angles. That's the one we cannot tackle. Okay. All right, I'm going to ask you to try this skill underneath here. Okay. I'm going to actually say solve for side A and B. I'm going to ask you to solve for both sides. By the way, what do you call it if you solve for all angles on all sides? What does the question usually ask when they want you to solve for everything? Solve the triangle. Okay, if the question ever says solve the triangle, it means solve everything. All angles, all sides. Okay? So can you try this? Give this a try. See if you can figure it out. You may have to use sum of triangle to get you started. There are the answers if you want to know if you're on the right track. I will stop this one in a bit, and then we'll learn how to solve for angles. Okay, that's our next step. So this is the hidden pair. So if you think you can't have a pair, try to figure out an angle that's missing perhaps. So angle C is 180 minus 85 minus 30. Angle C is 65 degrees. That's important, okay? Once you've got 65, now you have your pair. So you just start with it, okay? Sine of 65 over 14.5. And then you're gonna, if you want to solve for angle for side A, right? This is my unknown, then you have to use this one, okay? Sine of 30 over side A. And I saw a lot of you already having this solved, so I'm not too worried about it, but A is 8.00 meters. Okay, can I just say something here? This may look irrelevant, like why do you put the 2 zeros there? But if there was something past the second 0 that you cut off, the province actually wants you to put 0, 0. If your answer was exactly 8.00000, so it's all zeros after, then you're not cutting anything off, then you could just answer 8, okay? But I would just say if you want to get full marks and never risk losing marks, just put two decimals every time, round it correctly, you'll get the full marks, okay? Let's do this again. I'll go sine of 65 over 14.5. I'll go sine of 85, side B. Okay, so you cross multiply and divide. Side B gives you 15.94 meters, as I already told you earlier. So 3 lines is all I need. 3 lines is all I need. You're going to lose marks if you do this. Don't copy this down. But I have students, I don't know, I feel like sometimes it's just not wanting to do the extra work, but this is actually incorrect. This whole thing is not equal to 15.94. It's only B that's equal to 15.94. So please don't do this. Show me the work and then the final mark. If the province asks you to show work, this is next year, right? you will not get full marks. You will get a maximum of 1 out of 2 if you don't show work. So this is showing your work, okay? I'm going to stop there. I'm going to stop the video.